Hey guys, so in this video I'm going to be answering this question about the effect of gravity on Jupiter. So the height of a rock dropped from 20 meters is given by, we are told, this function right here, where h of x is equal to 20 minus 13x squared. X is the time measured in seconds. So this is height as a function of time is equal to 20 minus 13x squared. And the three questions we were asked are, one, what is the height after 1.1 seconds? When is the height 10 meters? And three, when does the rock hit the ground? All right, so I'm going to answer those questions right now. So our function, h of x is equal to 20 minus 13x squared. We want to know what is the height h after 1.1 seconds. So we want h of 1.1. We're given h of x is equal to 20 minus 13x squared. We want h of 1.1. So this is part one. We want h of 1.1. Well, h of x is 20 minus 13x squared. So therefore h of 1.1 will be 20 minus 13 times 1.1 squared. So our height, 1.1, is therefore equal to this. For this, it's just easier to use my calculator. So I'm going to break out my calculator. I'm going to work out 1.1 squared. Then I'm going to multiply it by 13. And then I'm going to take that number and subtract it from 20. So 1.1 squared is 121 over 100. I multiply that by 13. I get 1573 over 100. So let me just write that down. So it becomes 20 minus 1573 over 100. That is the same as 20 minus 15.73. And the calculator tells me that that is equal to 4.27 meters. And so, on Jupiter, this rock was dropped from a height of 20 meters. After 1.1 seconds, it was at a height of 4.27 meters. That is, it had fallen a distance of 15.73 meters. And that's the first part of the question done. All right, second part of the question. Just put it right here, perhaps. This is part two. When is the height 10 meters? So again, we're given the function h of x, where x is time in seconds, and we're asked, when is this function equal to 10? So what I'm going to do is I'm going to take my function, h of x, and I'm going to let it equal to 10. Well, h of x is 20 minus 13x squared. 20 minus 13x squared. And if I let that equal to 10, I can now solve for x, which is the time. And so, subtracting 20 from both sides, I will get minus 13x squared is equal to 10 minus 20. In other words, minus 13x squared is equal to minus 10. And then dividing both sides by negative 13, I'll get that x squared is equal to a negative over negative will give me a positive 10 over 13. In other words, x is equal to the square root of 10 divided by 13. Again, I'll break up my calculator. 10 divided by 13, and the square root of that answer gives me 0.0.88 to two decimal places, 0.88, and that is in seconds. And so I find that the height of the rock reaches exactly 10 meters. It means it has fallen halfway, started at 20, it's now at 10 after 0.88 seconds. All right, so that's the second part. Finally, third part of the question. when does the rock hit the ground? Well, the rock hits the ground when the height of the rock is equal to 0. So what I'm going to do is I'm going to take my function h of x, and I'm going to let it equal to 0, and I'm going to solve for x. So the rock will hit the ground when h of x height is equal to 0. In other words, when 20 minus 13x squared is equal to 0. And so now I can solve this equation. I'll add 13x squared to both sides. I will get 20 is equal to 13x squared, and therefore x squared is equal to 20 over 13, and therefore x is equal to the square root of 20 over 13. I will take a positive value. It's 20 divided by 13. The square root of that answer gives me 1.24 seconds. And so that is the amount of time it takes for the rock to hit the ground on Jupiter.